Hi all, welcome to the second part of the pandas tutorial. So in this we'll continue our discussion on the pandas. So let me first load both NumPy and Panda library. And what we are going to do, we are going to look at the arithmetic and the alignments part of in the pandas. So first we are going to create two series. So in this were these the four element series and the index we are providing A, B, A, C, D, E. Second one is again the second series where there are five uh, indexes, right? We are getting five. So this S1 is the first series, A, C, D, E, and S2 is the second series with the five element. So if we do the addition of these S1 plus S2, what's going to happen? So when we do the addition, it's going to look at the index. So in this case, A from S1 series, and if it's index for S2, and if they match, then it's going to perform the addition. And if the value is not available, and if you try to add, let's say 3 plus NaN, value is not available, then the result will be Na. So in this case, the A is available, right? C is available, D is available. D is not available, that's why it's so why you will think about D is available here, but D is not available. So it should give 3.4 values. No. So if you try to add, like in this case, so just a second, yeah. So think about like that. If you are adding 3 plus NaN value, right? It's going to throw an error, right? NA is not defined, or let me just write the np dot nn. The result is nan only, right? So in this case, 3.4 plus nan is result in the nan. That's why the d is nan, and likewise the other index value is also nan. Let's do the same thing with the data frames. So let's create two data frames here. df1 is the one where the index is what Ohio, Texas, Colorado, and the D2 we have the Utah, Ohio, Texas, Oregon, right? Now again we are trying to add these two data frames. So B from Ohio, the value is 3, else all the values, most of the values is NaN because the same reason. If we try to do the 3 plus NaN, the result is NaN. And NaN plus NaN is also NaN, right? Let's create redefine our df1 df2 again, and in this case if you want to extract, right, let's change one value here. So in the df2 b column, the first value 0 1 6 will update with an n, right? And now we again try to do the addition. So same thing, it's if the value is both the values are available with this with respect to the index, then it will update, it will add, else it will return an n, not a number. You can use the add function of the data frame itself, data frame dot add, and fill the values with 0 or something if required, and then the operation you will result in the actual value. So if it will be 3 plus 0, then the value will be 3. You can do the division 1 by divide, right? And it also has the data frame also has the same value. One function r div which do the same operation, same values. Let's also see the operation between the data frame and the series. You can think about like the matrix and 2D matrix and 1D matrix, right? Let's create a array of 3 by 4, right? And let's divide this array with the first uh, rows. So this will result all zeros in the first row, right? All zeros in the first rows. Let's create a data frame. All right, we have the column BDE, and these are the indexes and these are the values, right? And let's create a series out of this. So what it did, it asked for the first Otaha, right? And it created the series out of it. And if we do the subtraction from the frame minus series, it will result in the first row zeros, right? All zeros. Let's create the second series. Here we are using the arrange 0 2, it will result 0 1 2 and the index is BDE, sorry, BEF. And if you try to do the summation of frame plus series, again the same thing. If the value is available with respect to the index and the column, it will result in the addition, else it will result in NaN. Let's check some of the functions, application, and the mapping. So in this case, we have creating one data frame. We are choosing data in this case from the standard normals values. The matrix is 4 by 3, right? 4 rows, 3 columns. And we can do the operation like the absolute, find the absolute. So there are some negative value, it will generate into the positive values, right? The minus 2 becomes 2. Apply method and apply is very important, mostly used. What it does, it's apply if there is a function available and you want to apply all these function to your data frame or the series, it will apply that like this. So we created the function f where what it returning, it returns the maximum and minus the minimum value. And what we are doing here on this frame, we are applying this function in this function across the axis, right? And it will return across all the columns. Next is we are uh, returning the series instead of one values, right? And same thing in the min and max are the indexes we created for B is this is the minimum, this is the maximum value. Next one we are formatting. We are asking to change the format of the element in the data frame to 2 decimals, right? Same thing in this case we are using apply map method. Sorting and ranking, very important. So in the sorting and ranking is what? So if there are values in the series or the data frame, you want to sort it using the index or using the value. There are two main functions are available. Sort index will sort based on the index, right? In this index, it is not sorted. So if you use this, it will become sorted. If you want to sort based on the values, this part, then you can use sort values. Similarly for the data frame, so this is a data frame we have and we want to sort based out of the index. So one will become first and then three. And the values you have to provide on using which column you want to sort it. Like in the Excel, it's the same thing you provide sort based out, select the column and then sort it. Same thing here. So based or B sorted, you can also change it to ascending false and it will now sort based on the descending. Next one is for rank. So rank function, it will give you the equal value or assign a rank that is the average of the rank of those values. So if this is a series and want to enter rank, so it will assign the average value of this complete series to the particular index. Axis with the duplicate label. So whatever we have seen till now in the data frames and the series, we have the unique axis, right? But that is not the case in the actual data. You will get duplicate values in your axis, and what how to deal with that. So in this case we'll use the unique method which will give you the unique values in your index. So let's create the series with duplicate index. So in this case AA, B, B, C, these are the duplicate index. And if you extract the A, give the A, so it will give you the full two values, right? And if you want to check whether it is unique, so it will give false because these values are not unique values. Similarly for the data frame, right? If we have AA, BB, and CC, and if you extract using A, it will give you the two values. So let's also see some of the descriptive statistics available function which are available in for series and data frames. So let's create one data frame, right? It has two columns, 1 and 2, and these indexes are A, B, C, D. If you want to make a sum, right? I want to make a sum out of it, and then we can use the data frame function dot sum. So what does the summation? It will do the summation of the column wise, right, for A and 2. Now you might be thinking, why? How can the value is not available in A and it's still giving you the sum of that? In so what happens? It in by default, it is keeping the NAs, and if you don't want to skip the NAs, you can use skip NA equals to false, right? And in this case, because the NAs are available, it will return NN because you cannot do the addition with with the unknown value, right? X is one represent to do the summation of the row wise, right? And mean again, mean is nothing but to give you the average values for A full A and B like this. If for mean actually there is a one, if one value is available, that is fine too. It don't have required like it required one value to be available. If both the values are NA, then it will return in the NA. Like in this case, both C, both the values are NA, it will return it returned NaN. If you want to do the column wise, again the same thing. Axis one and column both represent same thing. That's why the results are same. IDX function is nothing but it will check the indices and give you the maximum values where it is located. So in this case, on the one column and B index, the maximum value is available. You can check 1 and B 7. Minimum is nothing but it will give you the minimum value and describe very important. It will just summarize, give you the different statistics in your data, like how many values are there, what is the mean of there, what is standard deviation, what are the minimum values, 25 per quantile, right? And median values 75 are the maximum values. Similarly on this series, if what is the unique here, so in the data frame we have all the numerical values, so it described differently, but in if your data is available in the non-integers values, so it will give you a different description. Like in this, the total count is 16, unique values 3, top values A, frequency is 8. Next is the unique values, the value count and the membership. So unique value is nothing but, as I told, there can be the scenarios in the index or in your actual value. If you want to identify, like in the case of set data structure, which you give with routine unique values. Similarly, if you create a series with duplicate values, you can find out the what are the unique values using a unique function. And if you want to get the counts, so it will give you how many times C is available, A is available, and you can also sort it, right? You can sort index or sort value, right? In the case of data frame, it's a different thing because let's say for q1, right, this column you want to do the count and sort index, so it will give you. But if you do on the complete data frame, it will give you tuple. So in this case, this is the data frame, right? It has a uh, duplicate values like 1 1 1 1 1, and you want to save the value count of it. So what happens here, so it it has taken the tuple, so 1 0 1 0. So this is two times, right? That's why it is 1 0 1 0, two times 2 0 2 0 two times, and 1 1 is one time. So that's what the value counts on the dictionary. So that's what we are ending the very basic details on the pandas, and we'll move to the in the next section. We'll see how to load the files and start doing more on the data analysis part by loading the data, how to load the data, different type of data into the Python, and how to start doing the data analysis. So we have covered the basics of Python, NumPy, and Pandas till now.